Okay, so we're going to work on some more chemistry for anatomy and physiology. And so here's where chemistry for biology starts to differ from real chemistry. We're going to start talking about chemical bonds and the properties of different things that have chemical bonds. And in chemistry, we start dealing with chemical reactions and balancing equations. And I want to say from the start, chemists are really nice people. Okay, it's not everybody likes them, and some people think that chemists are evil, but it's a tough job. Somebody's got to do it, and they have word problems every day, and no one says thank you. So they're really nice people. We won't have we won't balance chemical equations. We won't do stuff like that. But we do have to know basic things about chemistry. So we last time we talked about atoms, that the smallest pieces of matter that still have all the properties of the matter are atoms. And atoms have protons, neutrons, and electrons. The number of protons they contain determines what type of atom and their main properties. Atoms of the same type are part of an element, and they have similar chemical properties. But not, you may have figured this out, not all types of matter are elements. Sometimes uh, atoms form compounds where two different types of atoms join together, and they will exchange or share electrons and thus form a new type of material that will have different properties from any of the original atoms. And so, what happens with to form chemical bonds is that the outer electrons of an atom, these are called the valence electrons, kind of get rearranged to form a more stable atom. And even though it might have a charge, that arrangement of electrons is more stable. And so these valence electrons can be shared or they can be exchanged. Okay, and so the two basic types of chemical bonds are ionic bonds, where one atom loses a single electron or maybe sometimes two electrons, and then another atom picks up that electron. Those become then charged ions. An ion is just a charged atom, and the uh, oppositely charged ions are attracted. Or sometimes the atoms form covalent bonds where they share electrons. Okay, and sometimes that leads to most electron sharing is pretty equal sharing, but sometimes you have polar covalent bonds and hydrogen bonds, which are due to unequal sharing. Okay, so let's go into more detail on ionic bonds. Ionic bonds form between atoms because of the transfer of one or more electrons. Ions are the charged atoms resulting from the gain or loss of electrons. Okay, negatively charged ions are called anions. And so they've picked up a negative charge because they've picked up an electron. So they're always negatively charged. Cations have a positive charge because they've lost an electron. And so they have extra protons. Okay, so when you do this, you form ions, and then the ions are attracted to each other. Okay, and so here a sodium atom has one electron in its outer valence shell, which is very unstable, so it gives that electron up and becomes a sodium ion. Okay, and so it has a positive charge. It has more protons than electron. Chlorine electrons or chlorine atoms have 7 electrons in the valence shell, and to fill that shell they need 8, so they're very eager to gain an electron, and so then they become chloride ions. Okay, and the chloride ion has an extra electron. Okay, and the chloride then is attracted to this chloride ion is attracted to the sodium ion, and this changes the properties pretty dramatically. Sodium Regular sodium atoms form a metal, and that metal is strongly reactive, so it's almost like explosively reactive. Chlorine atoms are very light and they're gaseous, and it's a poisonous gas. And so sodium and chlorine in their normal states are very dangerous materials. But when they react in water, they form sodium chloride, which is a more stable arrangement of electrons for both the chlorine and for the sodium, and that's table salt. So completely different properties. Okay, so lots of things in the body occur as ions. This is just a list of some ions, but we have lots of different types of ions in our body solutions, and they're important for the functions of our cells. So we'll refer to those. Okay, the other type of bonds are covalent bonds. Covalent bonds are formed by the sharing of electrons, and so it's always sharing in pairs. So one electron from each atom. Okay, and so here shows on the upper part, it's two hydrogen atoms, each having one electron in the valence shell. In this case, the valence shell is only half full, so these two atoms get together and they share the electron pair and they form a molecule. It's not a compound, but it's a molecule where two atoms are together. If they were two different types of atoms, we would call it a compound. And so the double covalent bond is just sharing two pairs of electrons. Okay, electrons are not always shared equally. If they're shared unequally, that means the electrons spend more time near one atom than the other atom. And so like this is a water molecule here, H2O, and oxygen holds the electrons tighter than the hydrogen, and so the oxygen becomes negative. It has a partial negative charge. And so it acts like a negative pole to the molecule, and the hydrogen will be the positive pole. Okay, hydrogen in water like this, hydrogen of one oxygen or one water molecule will be attracted to the oxygen of another water molecule, and this attraction is called a hydrogen bond. It's not a true chemical bond, it's just an attraction. But this is what makes water so unusual, that water is attracted to other water molecules. It's also, so water is very stable at its temperature. It remains a liquid. Water also is a very good solvent because it's kind of partially negative and partially positive, partially ionic and partially covalent. So water has these unusual properties. It's a good solvent. It has stable temperature. It can participate in lots of interesting things. Okay, so I mentioned we're not going to talk about energy too much. Chemical bonds create energy. There's chemical energy stored in chemical bonds, but we're not going to calculate any of that. We're also not going to balance chemical reactions. We'll talk about them when they occur, but we're not going to balance them. We're not going to figure out equations or anything like that. What we want is basically to know that atoms may interact to form chemical bonds. Chemical bonds form molecules, it can form ions, and it can form compounds. Atoms share electrons in covalent bonds, and atoms transfer electrons in ionic bonds. The chemical properties of molecules and compounds differ from those of the original atom. Water is a really good example of that. Water contains two hydrogen and one oxygen atom, and it has unusual properties because of the covalent bonds. Most of the human body is water. Okay, so one more program on chemistry. It's not that bad. We'll get through it.